All right, guys, welcome to your review test study guide. This is our first review test. The questions are based off of the practice problems that you've been doing on the College Board. So I just kind of went through all those questions and picked out a variety of the types of questions that we went through, and we're going to go through them all here. Just some things to keep in mind as you do a review test is these are the skills you want to make sure you know how to do. Do you know how to find an average rate of change? See number 1 on this study guide. Do you remember how to find the derivative of an implicit function? If not, see number 16. And you want to know all your derivative rules. So product rule, quotient rule, chain rule, power rule, exponential functions, ln functions, and trig functions. And there's a lot of other. Actually, there's not a lot more, but there's a few other derivative rules, but they won't be on this test, and the reason they're not on there is because they weren't on your College Board practice. But that's the kind of stuff you can expect to see, and then we'll go ahead and go through some sample problems. So here's number 1, a sample problem for number 1. So let f be the function defined by this. The average rate of change of f over the interval from a to 3, where a is less than 3 is -10. Write an equation that could be used to find the value of a. So the average rate of change is -10 on this interval. The way that you find an average rate of change is, and I just realized I have a typo. This is supposed to be a G right here. The way that you find an average rate of change is by this little formula here. The number that comes second goes first in the formula, and the number that goes first goes here, and then same thing on the bottom. And then that's the average rate of change, which we know equals 10. You could even take it one step farther, and you could say, okay, well, since g of x is equal to x cubed, then that means this is 3 cubed minus a cubed over 3 minus a. So there it is. But that's as far as I think I'll go with that one. Let's go ahead and move on to number 2. And notice, by the way, I didn't solve this. I just wrote an equation because that's all it's asking me to do. Let's go ahead and move on to number 2 here. It says selected values of a function g are shown in the table at the right here. What is the average rate of change of g on the interval from 10 to 6? Well, it's another average rate function, right? So we have g of blank minus g of blank over blank minus blank. There's my numbers that go in the blanks, and the order does matter, right? The biggest number goes in first. So g of 10 is 5. G of 6 is 12. And so we have 5 minus 12, which is -7. 10 minus 6 is 4. Final answer, -7/4. That's the average rate of change. All right, let's go ahead and move on to number 3. An equation for the line tangent to the differentiable function f at x equals 3 is this. So this is the tangent line to some function. So we have a function. You don't have to draw this, but let's just say that this is the graph of f. And I've got a tangent line at x equals 3, so it'll look something like that. Which of the following must be true? All right. So, is it true that f of 3 equals 5? Well, let's see. At this point of tangency, which is at x equals 3, the tangent line has the same value as the f function. I'm going to write that up. At the point of tangency, the f function has the same slope and y value as the tangent line. Okay, so at x equals 3, f of 3 is the same thing as y of 3, where y is my tangent line. Well, y of 3 is 2 times 3 minus 1. which is 6 minus 1, which is 5. And so check, yes, f of 3 is equal to 5. All right, so that's a true statement. Let's move on to the next one. F prime of 2. Well, here's a problem here. Unlike the first one, 3, on the first one we did, 3 is the point of tangency. That's where the line is touching the graph. For part B, we're talking about 2, which is backwards a little bit. At that point, the tangent line isn't, my picture is not drawn well enough to be able to tell. But let's go ahead and say this is 2 right here. Back up and make that dot a little nicer looking while we're at it. So let's say right here is 2. Okay? And I'm just making this up. This is not really what the graph looks like. I'm just kind of using it to make a point. Haha, a point. All right. As you can see, this function, the f here, is different than the tangent line. At this point, this tangent line, since it's not touching that point, they have different y values, and they're also going to have different slopes. You could tell here that this tangent line has a positive slope, but if I were to look here, this one's sloping in a downward direction, so this is a negative slope. So at this point of tangency, we can't say that that's the same thing as y prime of 2. Okay, so we actually don't have enough information to say anything about what's going on at x equals 2 right now. So that's not necessarily true. It could be true. It doesn't look like it based on my picture that I drew, but remember, that's not really what the graph looks like necessarily. But the point is that we just don't have enough information. All we know is that since the tangent line is touching the function at x equals 3, we know that the function f has the same slope and y value as the tangent line at that point only. So that means that we can ignore d also, because they're asking about x equals 2 again. So I don't know anything about x equals 2 for my function. All right. But let's go ahead and take a look at f prime of 3. Now, for part C, f prime of 3. Well, now we're back to 3 again, right? And for 3, that is the point of tangency. And that means it's going to have the same derivative value as the y. Derivative is the same thing as slope. So the slope of f is the same thing as the slope of y at that point. The slope of y prime, is simply 2. If you just take the derivative of this, you're just left with a 2 and the 1 goes away. And so this is also true. So for this problem, A and C are true, B and D are not. All right, let's go ahead and move on to next question. I think we're on number 4 now. Shown below is the graph of a differentiable function f along with the line tangent to the graph at x equals -2. Find the value of f prime of 2. Well, f prime of 2 is the slope of f at x equals -2. Well, the slope of f is the same as the slope of the tangent line at x equals -2. So the slope of my curving function is exactly the same thing as the slope of my tangent line at that point, because that's the point of tangency. Remember what we said in the last problem, at that point of tangency, the tangent line has the same y value and slope as my function at that point. So if I want to find out what f prime of 2 is, I just need to find the slope at x equals -2, and that's the same thing as the slope of the straight line. So how do we find the slope of the straight line? Well, you just need to look at your run and your rise. Pick 2 points on the straight line and find your run and rise. My run is to the right one space, and it's up 2 spaces. Moving to the right is a positive, and moving up is a positive. Remember that moving left and down, those are negative values, but right and up are positives. So here's my rise, here's my run, and so it's 2 over 1 is my slope of my tangent line, which means that's the same thing as my f prime of negative 2. And so final answer is 2. All right, let's go ahead and move on to question number 5. All right, so this one says, let f and g be differentiable functions such that f prime of 0 equals negative 2 and g prime of 0 equals 5. H equals this. Find the value of h prime. So basically, this is a two-step problem. Step 1 is to find the derivative of h, and step 2 is to plug in 0 and solve. So let's do our derivative. The derivative of f is f prime. Constant multiple, the constant stays, but we do take the derivative of the g. Here we take the derivative of e to the 2x. That's going to be a chain rule. When we take the derivative of an e function, it stays the same, but we do multiply it by the derivative of the inside. Finally, the constant rule, if we take the derivative of a constant, it just becomes 0. Next, we go ahead and plug in the 0 that they give us. All right. Well, f prime of 0, as it says up here in the instructions, is negative 2. G prime of 0, as it says up here in the instructions, is 5. This is 0, and e to the 0 is 1. So we have negative 2 plus 10 plus 2, which is 10. All right, let's go ahead and move on to number 6. The graph of the function f consisting of 2 line segments is shown below in this figure. Let g be the function given by this, and let h be the function given by this. We want to find that. So, once again, same 2 steps as the last one. It's going to be, first of all, we want to find out what is h prime of x, and then after that, we want to find out what is h prime of 1 by plugging in 1 to our derivative. So this is going to be a chain rule. Now on your test, is it going to be a chain rule problem? I can't make any promises there. You just need to know your derivatives. The point is take the derivative and plug a number in. But it's up to you to remember what derivatives to use and how to use them and when to use them. So for this one, we have h prime of x. We do the derivative of the outside multiplied by the derivative of the inside. And then plugging our numbers in, we have this. Now we'll go ahead and simplify it. G of 1, that's the y value of the g function when x equals 1. So in other words, we're just going to take this function up here and we're going to plug in 1 and we're going to see what we get. Okay, so I'm going to show my work here off on the side. One plus 5 minus 3 is 3. So g of 1 ends up being 3. Now I also want to find g prime of 1. All right. So to find g prime of 1, the first thing I need to do is find the derivative of g, which is 2x plus 5. And then I'm going to plug in 1 to my derivative. Sorry, I'm having a technical difficulty there. There we go. 2 times 1 plus 5 is 7. The last thing I want to do is I want to find my value here, f prime of 3. All right, now if this was just f of 3, it would be asking me to take a look at this graph of f and find the y value when x equals 3. But I don't want the y value because this is a prime. So I want f prime of 3, and that's the slope of the f function at x equals 3. So here's where x equals 3. So they want me basically to find the slope of this line. Okay. So if I go from this dot up here to this dot down here, since it's a straight line, I can pick any 2 dots I want to. And all I have to do is find the rise and the run. So it looks like I'm going down 4. and then right 8. So this is my rise, and this is my run. And so that's negative 4 over 8, which is negative 1/2. And if you multiply those together, you get negative 7/2, and that would be the final answer there. All right, let's move on to the next one. All right, so once again, very similar process to the last two. We're going to take the derivative, and afterwards we're going to plug a number in. Pretty simple. So before we start taking the derivative, though, I want to rewrite a couple of these. X to the third is fine. But this guy, we need to rewrite that as x to the 2/3. And this guy here, we want to rewrite that as 5x to the negative 2. We want to rewrite them as exponents only, because we're going to do the power rule. So the derivative of this guy is 3x squared. The derivative of this guy is 2 over 3 x to the negative 1/3. And the derivative of the last one here is negative 10x to the negative 3. And then after that, we want to rewrite it again. So this is going to be 2 over 3. Now this is going to go to the bottom, and I'm also going to rewrite it as a root, like so. And then this one, that's just going to go to the bottom also. So there's my derivative, but they want me to plug in negative 1. So let's do that. Okay, so negative 1 squared is positive 1, times 3 is 3. The cube root of negative 1 is negative 1. And negative 1 cubed is negative 1. And so this becomes the following. Okay, so the negative here causes this fraction to become negative, and this negative causes this one to become positive. So I'm going to put my positive numbers together, 10 and 3, that makes 13, minus 2/3. The next thing we want to do is get a common denominator, which in my case will be 3. And so multiplying the top and the bottom by 3, we get 39 on the top here. And that leaves me with a final answer of 37 over 3. You guys have it. So basically the point of this one is just see how well you know how to do the power rule. All right, let's go ahead and move on to number 8. Let f be the function f of x. They want to find f prime of 3. Same thing. They just want me to take the derivative and plug in the number. So the last like 4 problems have been the same thing. They all require different skills, but they've all been pretty much the same thing. We're just taking a derivative and plugging a number in. So you'll see quite a few of those then on your little exam, I would imagine. All right, let's go ahead and move on to number 9. If y equals this, find the derivative. So now this is the test of how well you know how to recognize and apply the chain rule. Okay, so we have 3 functions here, but before I identify them, I'm going to rewrite it a little bit. When you see a trigonometric function written like this, what that really means is you're squaring the entire tangent function. So I'm going to write it like this. Okay, so we have our outermost function here is a square. We have our innermost function is a 3x. And then everything else is what we'll call the middle function, because it's not the outer, it's not the inner, but it's the middle function. And so basically what we're going to do here is we're just going to apply the chain rule. So here we go. The derivative of the outside. you're going to take 1 away from the power, and you're going to move the original power up to the front. And all of the inside stays the same. Next, we're going to do the derivative of the middle function. That's the tangent. The derivative of tangent is secant squared. Next, we're going to do the derivative of the inside function right there, and that's 3. And the only thing I would say that we really need to worry about here is multiplying the 3 and the 2 together. So here's what your final answer should look like. We don't really need to keep the power of 1 because the power of 1 is negligible when writing it out. But there would be our final answer. So it's a double chain rule. We likened it to an egg back in the day when we did it. There's a shell, a yolk, and an egg white, right? Same thing there. All right. Here's another one. We don't see these too often, but basically I'll write the rule up here again for you. The derivative of these guys is you get the exponential function again, but you're going to multiply it by ln of whatever the base number is, which is a. So that's the derivative of those. And that's what we're going to have here, but it's also a chain rule. Okay, so we have the inside function in this case is the exponent itself, 2x. And the outside function is this 3 to a power. Okay, so the derivative of the 3 to a power is ln of 3 times the original problem. So that's the derivative of the outside. The derivative of the inside, of course, is simply 2, right? That's pretty easy. So I'll just put times 2. I don't think it really matters what order you put these things in. We just have 3 things being multiplied together, though. Right? So that's that. Let's go ahead and move on to another one. These questions are interesting. So we have f prime of 1 here, and then here's f. So what we're going to do is we're going to find out what f prime of 1 is first, and then we're going to replace this with that value, and then we're going to simplify it. So let's first of all find out what f prime of 1 is. So if this is f, then f prime is the derivative of this function, which is 1 over x. You have to remember how to find the derivative of ln. And then f prime of 1 means I'm going to plug 1 into that, which is 1. So e to the power of f prime of 1 becomes e to the 1. And that's as simple as that gets. You can't do anything else with it. So the answer is just e. Let's do this one. For this one, should have some instructions on it. Let me add them there. So we want to find the derivative of this provided that a is a constant. So basically, these questions happen sometimes. They're kind of weird, but basically there's usually what we would have. They're saying this is just a number. Basically, we don't know what the number is, so they put a letter, but it's a number. So it's not a. We don't want to think of it like a variable that we're going to be doing derivatives of. It's rather, just think of it like a constant multiple, in other words. So here we go. So when you're doing the derivative of this function here, the derivative, the outside function is the e function. So let me write that. So we have e to a power, right? So that's my outside function. You can also include the plus 4 in that as part of the outside function. But the inside function is this ax squared. Okay, so let's do the derivative of the outside. Now, the derivative of an e function is that it stays exactly the same. It doesn't change. The 4 is a constant rule, not a constant multiple rule, but a constant rule. And with those, it just goes away. It's 0, right? Now, we want to multiply this by the derivative of the inside. And so when you're taking the derivative of ax squared, we're going to multiply the 2 to the front. Because usually we would just multiply this exponent by whatever number's in the front. Well, in this case, my number's a letter, but it is just a number, so we're going to treat it like a number. So it's 2 times a, x to the first power. And that's it for that one. So that's as simple as that one's going to get. Just a chain rule with a letter that represents a constant, basically. All right, here's another one. If y equals x times ln of x, then find the derivative. So this is do you know how to do a product rule? So for our derivatives, this is a product rule because I have something being multiplied by something else. So product rule looks like this, where if I call the x a and the ln of x b, we have ab, prime the a here, prime the b there. So a prime is 1 because the derivative of x is simply 1. B is ln of x. A is x. B prime is the derivative of ln of x, which is 1 over x. Now, if we multiply these together, you get x over x, which is simply 1. If you multiply these together, you get ln of x. And so there is my final answer, ln of x plus 1. All right, let's go ahead and move on to the next one here. This is just really a test of your trigonometric knowledge. So we want to take the derivative of g first, and after that we're going to plug in the angle that they give us here. So the derivative of cosine is negative sine. So you want to know that first. Second of all, we want to be able to find what is sine of 2 pi over 3. And it's going to be negative, whatever it is, because there's a, well, we're going to make the answer a negative because there's a negative in front. So sine of 2 pi over 3 is radical 3 over 2. And so my final answer is simply that. All right, let's go ahead and move on. This one is crazy, but sometimes they're going to throw crazy ones on you on these AP exams. So it's a chain rule on steroids because we have quite a few pieces. We have the outermost function, which is the sine. We have the next leveled function, which is the ln. Then we have a absolute value function in here as well. And then finally we have a little function here that looks like this. So basically we need to find the derivative of each one of those types of pieces and do their derivatives. So the derivative of sine is cosine. So when I do that, everything's going to stay exactly the same except for the outside piece. Next, we're going to do the derivative of ln. The derivative of an ln function is you do 1 over whatever's inside of it. Next, we're going to do the derivative of this absolute value function. And for an absolute value function, we put whatever's inside the absolute value over whatever, or over the original problem itself. So that looks like that. And then finally, we have the 3 over x. Now to do that one, the first thing you want to do is rewrite it and then do the power rule. So multiplying the negative 1 to the front, we get negative 3. I shouldn't put an equal there. The derivative, though, will be negative 3x to the negative 2. And then putting that in the bottom, we end up with negative 3 over x squared. Now that's a lot, and I think that the first thing that's difficult is recognizing all the pieces and multiplying all the pieces together, but there they are. Those are the outermost up to the innermost function all being multiplied together according to the chain rule. Okay, so that's the first part, makes this one a little bit challenging. The second thing that makes this thing a little bit challenging is the simplification. So first of all, we can put these two fractions here together. And by doing that, we get 3 over the absolute value of 3 over x squared. Now, oops, I forgot this is 3 over x. Okay, so now we have an absolute value, which makes it simply positive, being squared. But a square also makes it positive. So we really don't need the absolute value if we're squaring it. Okay? So what this simplifies into then is the following. we could rewrite it as 3 over x over 3 over x squared. We don't really need the absolute value if we're squaring it. Now, if we were cubing it, you would have to keep it. But in this case, we don't need the absolute values. And the reason I want to get rid of them is because that allows me to simplify this a little bit. Okay, so 3 over x squared can be rewritten as 9 over x squared, right? Also, this is a complex fraction, so I don't like the way this looks. So I'm going to multiply the top and the bottom by x squared, and let's see what we get as a result. By doing that, these cancel, right? And I'm just left with 9. And here on the top, this x goes into x squared one time to leave an extra x left over. So now I'm left with the following, 3x over 9. I want to do black there. And there's that. We could actually probably reduce this even more, right? The 3 goes into 9 3 times. And so this really just simplifies into x over 3. Okay, so now we have cosine of all of this times x over 3 times negative 3 over x squared. We can simplify this even more now, right? Because we have these two. These 3's cancel out. And this x here goes into x squared once to leave an x left over. So now, putting all that together, I'm left with a nothing on the top, but we can't put nothing. We're going to put a 1. So, and there's a negative. So negative 1 over x. And then putting these things together here, basically we can just move the negative to the front and put that x on the bottom. And that's as simple as this thing is going to get. Okay, so it's kind of tough because you have a lot of chain rule to do. And also you have to put them together and simplify it, which is also a little bit tough. So that in my opinion is probably one of the hardest ones on here. But let's go ahead and take a look at the next one here. This is an implicit function. We're on number 16. So here we go. We want to find the derivative of this, and it's an implicit function. So to do that, we start off like this. Just writing it out like that with the derivative on the outside. For this guy here, we're going to take the derivative of that. Now, when we do that one, it's a chain rule. Okay, we have an outside function, which is the sine. And then we have an inside function, which is x squared minus 3y. So let's do this derivative. The derivative of sine is cosine. And then the derivative of the inside is 2x minus 3. However, remember, this is a y. And when you're taking the derivative of a y expression with respect to x, you get a y prime next to it. Okay? So there is that one. Then we're going to also take the derivative of 4x, which is 4. And the derivative of 5 is 0, so that just goes away. So now what we want to do is we want to get this y prime by itself. The first thing I would do is I would take this entire expression here, the cosine x squared minus 3y, and I would divide that to the other side. So that will look like the following. The next thing I would do is I would minus this 2x on both sides. So if I were to subtract it off of this side and subtract it to the other side, we would have that. The last thing I want to do is I'm going to divide this -3 out, so that goes away on this side. And you're going to put it on the bottom here, and you're going to put it on the bottom here. These two can become positives, so we might as well simplify that if we can. And I'm doing a lot more simplifying on this particular assignment because this is a multiple choice one, right? And so you have to know how to be able to simplify your work. So there's that. So our final answer there would be y prime equals all of this. So basically take the derivative and get the y prime by itself. Don't forget that when you take the derivative, the y part gets a prime next to it. And our last one we'll go over is this guy here. What is the slope of the line tangent to this graph? Well, the slope of a line tangent to this graph is going to be the derivative of that function at that value that they give you. So basically I have y, my function here, I'm going to find its derivative and plug in 0.5. Now this is going to be a quotient rule. We do low d high minus high d low, draw a line and square below. Now you'll notice I didn't do this part yet, and that's because it takes a little bit more thought, but we have low d high minus high d low, draw a line and square below. So this part here is low. This is the derivative of the top function. So how do we find this derivative? Well, it's a chain rule. Surprise. All right, seems to be everywhere, right? So the outside function is the ln. And the inside function is the 2x. So the derivative of the outside is 1 over 2x. The derivative of the inside is 2. These 2's cancel, and we're left with 1 over x. And that's what I'm going to put right here. Now in this case, x times 1 over x, they kind of just cancel each other out and leave you with 1. So we have 2 there. Minus ln of 2x times 2 over 2x squared. Last thing I'm going to do is going to plug in this 0.5. So let's do that. All right, so 2 times 0.5 is 1, and so I'm just going to replace both of these with 1 because 2 times 0.5 is 1. ln of 1 is 0, and 0 times 2 is 0, so this whole side just goes away and I'm just left with a 2 on the top. On the bottom I've got 1 squared, which is 1, and so my final answer is just going to be 2. I think that does it for us for today. So hopefully, that was helpful. These are all just similar questions to the ones that you guys have been working on the College Board assignment. Just kind of reworked the numbers a little bit, the same ideas. So know your derivatives well, and we'll see you guys, and good luck with your review tests coming up.